My name is Elliot Woods, and I'm one half of Kimchi and Chip's art collective based in South Korea. Today I'm going to introduce a project I've been researching with the City University of Hong Kong XRL Lab. This is a lab where researchers look into techniques for bringing the digital world into physical reality. At Kimchi and Chips, we exploit and critique technologies which mediate between the material and the immaterial. Our artworks often involve controlling physical fields of light, and often at large scale. This can be achieved using calibrated video projectors and curved mirrors to create a field of light in space. We call this a light field projector. Alternatively, we can use an array of steerable mirrors which use existing light from the environment and redirect this light in a controlled fashion. We call this a light field manipulator. By manipulating fields of light, we can create controllable illumination within an environment, we can create infrared heat couplings between objects, and we can create new interesting image formats. Into the future, we predict that light field manipulator systems will scale downwards in element size, upwards in frequency, and downwards in cost. This becomes particularly interesting when we approach the scale of a photon of light. Current commercial semiconductor processes regularly fabricate transistors which are 100 times smaller than the wavelength of visible light. Considering that a conductor and a mirror are electromagnetically the same thing, we can imagine that sub-photon scale addressable digital mirror arrays are feasible to fabricate, especially into the future. To begin experimenting with this phenomena, we are first developing a low-cost centimetre scale system for manipulating fields of light. A flexure assembly acts as a mirror, bearings, and springs. A pair of magnets are mounted onto the mirror, and external solenoids act against these magnets to create forces which drive the angle of the mirror. The combination of magnetic field from the magnets and solenoids can be measured locally by an array of Hall effect sensors in order to inform a closed-loop control system which drives the angle of the mirror. To keep the costs low, the manufacturing tolerances are relatively high. Therefore, the mechanics can be somewhat unpredictable, and therefore we employ reinforcement learning in our closed-loop control system in order to learn the mechanics of each module produced. We use a system we called muscle memory, whereby an actor and critic are trained centrally on a high-powered computer, for example in the cloud, after which the actor is transmitted to low-cost silicon where it can be locally invoked at runtime in a tight control loop. If you'd like to learn more about this project, then please follow either the XRL Lab, myself, or Kimchi and Chip's Art Studio for further updates. Thank you for watching.